When you hear the words greenhouse gas, your mind probably goes to carbon dioxide, the concentration of which has been steadily rising worldwide, leading to a feedback loop of absorbing and trapping more and more of the sun's energy with each passing year. Methane is another, considered a potent trace gas, and is about 28 times more effective at this heat trapping than CO2 is. We've known for decades that trees are great for capturing and storing much of these gases, yet the ability of their bark to keep the air clean has been largely overlooked. Enter Dr. Luke Jeffrey at Australia's Southern Cross University and his co-first author, Dr. Bob Lung from Monash University.
The end result wasn't something we originally set out to do, but we kind of stumbled across it after many years.
Back in 2021, Dr. Jeffrey and crew were looking into how methane produced by wetland soil is transported up through trees and into the atmosphere, when they realized there was a big gap between input and output, as much as 35% less methane making it out of the tree bark compared to what its towering host took in from below.
Our group had this idea that perhaps methane-consuming microbes might actually live in the bark of trees.
Specifically, the paper bark tree, an Australian icon with a lot of layered protection and a great case study for methane mitigating microbes.
It's rich in methane, it's moist, it's dark, and it just seemed like a too good an opportunity to look deep into the bark and see if these types of microbes that live in soils were also living in trees.
Through a process called metagenomic sequencing, analyzing all genetic material from a given sample, the team found a bunch of those atmosphere-boosting bacteria with the approximate number hard to wrap one's head around.
In the trees we've looked at, there's about 6 trillion bacterial cells in 1 square meter. This is definitely similar to what we find in soil and water, but for whatever reason, no one's really investigated what these bacteria do in trees.
A 2024 study suggests anywhere from 25 to 50 million tons of methane are taken out of the air by trees every year worldwide. Dr. Jeffrey acknowledges they were limited to one part of eastern Australia in their work, yet found many separate points of interest in that region alone.
We looked at 8 different tree species, but even within that small area we found there were kind of distinct microbiomes adapted to each tree species.
Carbon monoxide and hydrogen also act to keep methane in the atmosphere for longer, and the team found specialized microbes to take on those elements and compounds as well. With tree bark having a global surface area almost as large as all the land masses, Dr. Jeffrey says the next logical step here is to take their studies international.
Different latitudes, different tropics, subtropics, temperate climates, possibly northern hemisphere as well, as we expand our search for tree microbes. I think it's a very exciting research frontier that, our team is definitely keen to investigate further.
For this week's Moment of Science, I'm Dan Smith.